Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're going to see problem number 4 of today's bi-weekly contest. Again, problem number 2 is already discussed. 3 might not be coming in. Now, in this problem, we are saying that we are given a string S and a pattern P. Now, you will see that in the actual code and in the entire explanation, I have replaced the S with text and pattern, P with the name pattern. Just so that it is more readily having good naming convention. Now, there's a very important thing which I have written that P, which is the pattern, it contains exactly two asterisks or stars. Now, these stars in P match any sequence of 0 or more character. What they mean is, as you can see, for B A star, in place of the star, I can place any number of characters, including nothing as well. Same way, in this star, I can place any number of characters, including nothing as well. And I have to return the length of the shortest substring in S that matches a pattern P, and there is no such substring, return -1. Now they have written a substring is continuous set of sequence of characters. Obviously, as they are starting to mention about some form of a pattern being matched with some substring, you might be very much okay. I will use some regex or something that sort. If you use that, it will have a higher complexity. You have to achieve things in O of n plus m or O of n log n plus basically n log terms. You have to get things done, not O of n square. Now, coming on back, how can we achieve it? Let's see. So, if we look at this question, basically, let's say this example itself very carefully. Let me copy this example, but I want you to comment down below. Meanwhile, what was that approach which you thought of when you read this problem? And I always recommend please add that so that you remember what exactly you thought of and what you were missing. So our main string, pattern string was BA star C star CE. Now, one thing quickly, the like target of this video is 75 likes. Please make sure that we like that. Now, it simply says that a pattern BA should match. As you can see, we have a pattern BA here. Then a C should be there. Okay, a C is there and a C is there, C is there. But you will also recognize that I'm technically not concerned about this asterisk. Why? Because I know that these asterisks can have any number of characters, including including nothing as well. So in like I have to just make sure the sequence. Okay, BA should be there, C should be there, and CE should be there. Any number of things which comes in between is not my issue. Is not my issue. Okay. And if I am able to achieve that, I have to make sure that I have to take this in consideration as the length. Here the length is 1, 2, 3, 4, 5, 6, 7, 8. But if you see, you have one more such example. BA is here as well, C is here as well, CE is here as well. So this is also one such string which I can take in my answer. But this length is 1, 2, 3, 4, 5, 6, 7, 8, 9. But I want minimum length, shortest length. That's the reason my answer is 8 in this case. Did you see some very strange or very observant thing? Obviously, you are trying to figure out a pattern match, but obviously you want to have a pattern match of this prefix, you want to have a pattern match of this middle, and then you are having a pattern match of this suffix, and you are kind of maintaining that specific locations where the pattern match takes place. Now let's see how and what all we know. If you don't know or if you haven't studied about KMP, then KMP is a very a KMP is an algorithm which helps us in pattern matching. Although if you want just come here and write KMP, you will get the KMP video, KMP article. Just come down, this is explanation of KMP. Again, I highly recommend go and watch the video itself. Although people who are much interested in Rabin Cup, okay, you can watch that as well. We also have a video of Rabin Cup. I will link that in description. But the best part about KMP, again, let's say if I want to talk about Rabin Cup, we can just come up here and in strings, if I go down, And yeah, so you can come up here, you will see rabin carp single hash. Again, in crash course section, rabin carp single hash, rabin carp double hash, we have the corresponding. Again, obviously you have to implement rabin carp double hash, and you can do that by with that as well. But again, lps, or I should say KMP, is very very short and simple. This is the entire code of KMP which you can leverage. Now KMP simply says that, again, this is how we usually do it, that we have a pattern, we put up a hash, and then we have another such string, which is the main string, text string. Then our LPS array helps us build this kind of a LPS vector, which tells, okay, 3. 3 is the length of my pattern. Let's say if I zoom it a bit, 3 is the length of my pattern. 3 is the length of my pattern. So if I have at this location 3, which it ultimately indicates that I have found a pattern match at this location. Same way, I have found a pattern match at this location because the length has matched, length of the pattern has matched with the LPS. And with LPS, again, you can also use Z, you can also use rabin carp, you can also use KMP. Now KMP is the shortest, and again, people think it's tricky, but once you watch this video, you will find it not tricky. Now we can use KMP just to know all the occurrences of a pattern, both of prefix, middle, and suffix. So what I will do, I will have this prefix, this middle, as suffix. And why I was able to do this division into 3 such pattern strings? Because I know I have exactly 2 stars, which means I have exactly 3 patterns, because star is in between. So I'll have exactly 3 patterns, and I will divide that pattern as a prefix pattern, as a middle pattern, and as a suffix pattern. Then what I will do, I will do one thing, which means do a BA and then hash of this entire string. Let's say if I copy this entire string, which I copied it previously, I can just paste it right now. So this is how I build up my corresponding, what I pass in my LPS vector. As you know, that this is how exactly we also did previously, that we build up pattern hash text, and that's how we pass it to our function, which is, this LPS, compute LPS, and this gives us the LPS vector, which looks like this thing. And with that, although I'm only concerned about this entire portion, I'm only concerned about this piece of portion. Okay, it's not working, but yeah, I'm only concerned about this piece. Okay, yeah, my laptop is hanging, that's the issue, but no worries. I'm only concerned about, this piece of text, this piece, and that's only what I require. Now I don't know how to erase it, but yeah, let's go on. So we will just simply compute the LPS. With this LPS of 0 1, let's say if I build the LPS, I will get something of this sort: 0, and then 1, then 2, then 0, then 0, then 1, then 2, then 0, 0, 0, 1, then 0, and then 0. So this is, again, forget about this portion, although you will have something, but that is not required, because I will ultimately, after building the LPS, which is this, entire vector, I will also only make sure that I will take this entire portion, because I'm only concerned about this. Same way, I will take C hash this thing. What is this thing? This thing is, I have input string. If I have that input string, let's build the LPS vector. How it will look like? Let's simply erase that and build my LPS vector. It will be 0 0 0 0 0 1 0 0 0 1 0 0 1 0. Now lastly, if I have CE, let's build again. Obviously it will be 0 0 as well. Here it will be 0 0 0 as well. So this is how your LPS vector will look like. Okay, lastly, if I have another suffix pattern string, I will again try to build the same thing. In this case, I will have a pattern, suffix pattern, as CE 0 0 0 0 0 0. Again, if you don't know what this is, make sure that you check out the video itself, but this is how exactly it will look like. Now with that, I have built up my LPS vector. I will name this as my prefix LPS. I will name this as my suffix LPS. I will name this as, sorry, this is my middle LPS, and this is my suffix LPS. Now, when this LPS are built, now you also know that technically you don't need this portion. So starting from what? So this is the prefix pattern, this is the middle pattern, this is the suffix pattern. So starting from, you can say, prefix pattern plus one length, or you can say index, you can start take that prefix LPS, which means that updating your prefix LPS to only expect this vector, which means discarding these values and making a new vector by taking only this portion. Same way, middle LPS, discarding this portion of the middle pattern and taking this. Same way, suffix LPS, discarding this portion and taking this. Now, when you have built your prefix, middle and suffix, you can easily tell the indexes. You can easily tell the indexes. Now, if I tell the corresponding indexes, what I will have for BA, wherever it is coming up, I will be having that B again. Although I'm just showcasing you, that is not required for you to know, neither for the problem, but just for showcasing. BA, as you can simply see, BA is coming at index 2, okay, and also at index 6, okay, and also at which index? Okay, no other index. Okay, let's see. C is coming at index 4, index 8, index 11. It is coming at 4, 8 and 11. Okay, what about C? C is coming at index 9 and index 12. Index 9 and index 12. How did I figure out? By checking the value, which is the LPS value. If it is equal to pattern length, okay, that is where I have got it. Now, when I have this, ultimately my task is that I should take BA location. I should take BA at a specific location. Then next I should choose some index which is after this thing 2, right? And then choosing something from the middle index which is obviously larger than that, and then choosing something after this index. Also, again, there are some catch, some catch, saying how will you incorporate the length also of the middle element and all that stuff, and then choosing a final element or final index. So technically it boils down to that I can try for all possibilities of the prefix index. With that, I will try to choose the first possible index which I can find, and again, for example, if this index is 2, it has already, again, if this index is 2, it has already covered BA. So this index is 2. Now, after 2, you are trying to find the next index, which is higher than 2, which is, starting from 3 onwards. So I found the first index, which is higher than 2, that is 4. Okay. Now again, 4 indicates that I was finished at here, like finished at 4. But it should also make sure that if you are finishing at 4, whatever length of the middle pattern you had, you are making sure that that length and the difference between these two indexes should be such that the length of the middle pattern is taken into consideration. Cool. And then you will go and do the same thing for your third pattern, which is the suffix. Although you might have felt like that whenever I mention that, okay, search for the lowest index which satisfies this condition, it is more of searching for it, and obviously you are searching for something in a sorted vector. Obviously you can apply a binary search. If you apply a binary search, obviously building this LPS because of KMP will take O of n plus n time. But because of this binary searching in this index location, you will have a log n factor as well. Can you improvise that? Yes, you can. You will use 3 pointers. Although 2 pointers itself is pretty hard to many people, but still, no worries. Again, do nothing. If you want to study about 2 pointers, just come down here in the practice problem sheet. How you will get it? Just come down to DSA sheets, practice problem sheet. You will find a lot of problems regarding 2 pointers. Just make sure you study that and you will be good to go. Now, if not, make sure that at least you come to crash course section and go on to the array section, go on to 2 pointers and watch 2 pointers crash course at least. You have to watch this crash course if you want to know about 2 pointers. Coming on back, how I will use it. I will leverage that 2 pointer technique in my favor. How? Okay. I know I have to find 3 indexes I, j and k. Okay, 3 indexes I, j and k. I will simply keep on moving. Now, okay, I is here. And whenever I move my I, I'm looking for the prefix pattern. Whenever I'm moving my j, I'm looking for a suffix pattern. When I'm looking for a middle pattern, and here I'm looking for a suffix pattern. And how to know? I will leverage my prefix LPS, my middle LPS, and my suffix LPS to know that at a specific index have I found a pattern or not. Although I showed you that I can, leverage these indexes, but these are nothing which we have derived from these vectors itself. So I can use these vectors directly. Okay, let's start off. Let's start the dry run. Now, I will start by saying I. Do again, firstly, make sure I is matching with the prefix pattern. Am I able to match that? No, because here it says it's 0. Not able to match. Okay, move on your I. Am I able to match that? No, again not, because it should match with the pattern length. Prefix pattern length is 2. So anywhere in the prefix LPS I found 2, that is correspondingly my pattern match. Okay, now I move my I. Am I able to match that? Yes. If I'm able to match that, oh, I will stop my I here. This is my good candidate. Now I will start off my J. Now, the first thing is, from which point should I start my J from? Obviously, I should make sure that if my J, whatever J is there in the very beginning, my J is at 0, because, everything, let's say, in the very beginning is 0. This is 0, this is 0, and this is 0. So, obviously, that if my J is 0, and again, if my J is less than my I plus the middle length, then I should keep on moving my J and at least put my J onto a location, put my J onto a location that I can start off from my J, checking that J from that location onwards, which is after I, and also incorporating the middle element length, middle pattern length. Again, that also I explained while I was telling that you have to incorporate the middle pattern length. So if the middle pattern length is, let's say, 3, and my I, let's say, is 2, so I should at least start off from index 5. My J should at least start off from the index 5, right? This is how I should start my J. I cannot start my J from here, because if I do a start from J here and the middle pattern length is 3, then obviously it will end up something of this, which is the overlap between the prefix pattern and the middle pattern, which is not affordable. So make sure that you move your J until it is less than I plus middle length. Simply keep on moving your J. Now in this example, my J was in the very beginning 0, and my C pattern length, or I should say middle pattern length, is 1. Thus my J will start from here. My J will start from here. Okay, now let's continue. So my I'm at the middle pattern length. My J is at index 3. Is it 1? Is it equal to the pattern length? Is it equal to the pattern middle pattern length? No. Okay, move your J. Move your J. Is it 1? Yes. Okay, yeah, I moved my J and it is now here. I have found it. Okay, but still I have found only 1. Now move your K. Again, same concept apply here as well. That while I will move my again K should be moved until K is less than my suffix pattern length. So imagining your suffix pattern length is 2. So I should start my K at least from index 6. So I will come down here and I will start my K, I will start my K at least from this thing, which is 6. Okay, let's start off. Do I have 2? No. 2? No. 2? No. 2? No. Yes. Yes, I have found it. So K will stop at index 9. K will stop at index 9. So this is how I have found. Again, you see that I have only moved I once, J once, K once. So this is how they have moved. And again, because we know in a two-pointer approach, we only move things in one direction and only they are moving forward, you will see that these are not I, J, K loops. No, all of them are just moving once and are moving forward. Everything you will understand if you would have watched two-pointer crash course. Coming on back. Now, how to do it? Okay, right now I have this state of I, J, K where my corresponding pattern length, patterns are matching. This is my one such answer. What is the answer? Answer is from here. If I, let's say, erase this, so from here, starting off up till the index, up till this index, up till this index I, and obviously I is the end index of the prefix pattern, making sure that I minus prefix length is the prefix pattern length, is my actual string length. So technically my string length which I can get will be K minus I plus prefix pattern. K minus I is this portion, K minus I is this portion, and then the prefix length or prefix pattern length is including this portion. So this is what I can take as a substring. Now again, obviously this is my one such candidate of answer. I have to minimize that. Okay. Now currently, as you can see, it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is currently 9. Okay, no worries. Let's proceed forward. But again, as I say, let's proceed forward. I'm only making sure I will move forward. Everything will now just move forward. Okay, let's see how. Now, I have my I. I will simply move forward. Okay, try for this I. Now, as I mentioned, if this is a I, my C can still start from this point, but obviously my I should stop at a location which is his prefix. So my I is at index 3. My I is at, let's say, index 3. Now I should keep on moving until I find 2. Okay, I will obviously, because my pattern, my prefix pattern length was 2. So I will stop here at index 6. Okay, I stopped here, my I stopped here. Now J starting point will be from here itself. Okay, so come on here, and J starting point will be from here. Now keep on moving until you find a 1. Okay, I found a 1. Okay, stop at index 8. Stop at index 8. Okay, now your K starting point will be from index 10. Okay, come on here. K starting point will be from index 10. Now keep on moving until you find a 2. Yeah, I found it. Okay, this is a 2. Okay, so you found a 2 here. So K reached up till here. So what is the length now? Length will be same, this thing, which is 1, 2, 3, 4, 5, 6, 7, 8. And thus, obviously, again, this is one such answer. So earlier it was 9, now I got a 8. Okay, let's try for a further. Okay, I will try to move my I again. As I move my I again, my I is at index 6. My I is at index 6. Now try to move my I until you get a 2. Here I have a 2. No, 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 no. Oh, I reach the end. As soon as my I reaches the end, oh, I should actually break, which means I should stop my computation, and that is done. And same way, let's say if I still would have been here, sorry, if the I still would have been here, but my J would have broken, then again end the program. What if my K would have been out of the index? Simply break the program. Anyway, if you're not able to find it, because you want all three patterns to match, if you're not able to find it, you have to simply break it down. So again, as I mentioned, there are two ways to solve it: binary search or three pointers. Three pointers is much easier, and again, according to me, it is much easier and also more, having a better time complexity. Cool, let's see the code. Again, I did not discuss other examples, but you can easily see other examples as well. If there is 2 stars, obviously I can put nothing and I will match everything. If I have a pattern like this, you will see that CC is this, BAA is this, but ADB I cannot find because ADB will overlap with BAA. That's the reason answer is -1, because you cannot find anything which will match. And ultimately here you will see add logic. Add logic is this MNC. I can come have it or maybe not have it. If I have it, great. If I don't, great. But I will not have it 1, 2, 3, 4, 5, 6. So I only have this. I will not have CMNC because I will ignore it. I want the minimum shortest one. Cool, let's see the code. It's exactly same. Firstly, we use the LPS template as what we have discussed in our, KMP crash course. We use the exact same template and exact same methodology of adding a hash and then computing the corresponding LPS. So you will see that in the corresponding main function, I found my text length, which is, again, in the code, you will see it is S and it is P. I have changed it to text and the pattern. So I found my text length and the pattern length, which I will use in my follow-up code. Now, one base case, which is the pattern length is 2, you have to simply return 0 because obviously if the pattern length is 2, it means I have 2 stars. That's the only thing I can have. Then I found out that what is the corresponding star location I have. Why I am finding it? Because I want to know the prefix pattern, middle pattern and suffix pattern. That is the reason. If this is a star location, I can easily find the prefix pattern. I have this star location, so I can find between 2 stars what is the middle pattern, and after the last pattern, last star, what is the suffix pattern. So with the help of this star location, star position, I am finding the prefix pattern, middle pattern, and suffix pattern strings. When I have found that, I just took for as a reference their length as well. Then I found the prefix LPS, middle LPS, and suffix LPS. You will see I have attached prefix, middle, suffix, added a hash, and then a text. This is the exact same way as how we have done, just finding the combined LPS. It is much more easier because you are trying to find this pattern inside this text. That is the reason it is pretty much okay. Now, as a next step, what I will do, I will simply remove this portion. I will simply remove this portion. So here as well, you will see that the extra portion in the beginning, which is apart from text, apart, because this is a prefix pattern, this is the text with the hash here. This is the middle pattern, a hash and a text. This is a suffix pattern, a hash and a text. So I'm just removing these portions because I only want it inside the text, because I will iterate on text. My I, J, and K are on text. That is the reason I am simply removing it, so that I can have my iteration pretty easily and seamlessly, because my I, J, K are on top of this input text. And that is the reason I wanted that ijk to be very linearly associated, with my LPS of prefix LPS, middle LPS, and suffix LPS. Coming on back, we realized that, okay, I will find my prefix LPS, updated prefix LPS, middle LPS, and suffix LPS by simply making sure that I'm eliminating, the beginning portion and only taking the text length stuff. Okay, when I have done this portion, when I have received this portion, I am pretty good now. How? Now I can start my IJK 3-pointer traversal. How? Simply keep on moving your I until you have your I. You can also incorporate middle pattern, you can also incorporate suffix pattern, and it should be less than your text length, which is your entire text length is this, I is here. See, this is the middle pattern, this is the suffix pattern, and I will keep on going until this is less than my actual text length. Now, individually, I have 3 for loops. As you can see, this is representing the 3 individual movement of my I. Again, I mentioned cumulatively everything, every index I, J, K will only move forward once, which is, it is O of 3n time. That's it, nothing else. Cool. Now coming on back, I will move my I until I can move in the pattern, which means I is less than my text length, and also making sure that until unless you achieve your LPS value equal to the prefix length, you have to keep on moving. You will get out of here as maybe you find a prefix LPS value matching with the pattern length, which indicates, okay, my pattern match, my one such pattern match is found. In that case, I will be out. Or maybe I have extended, or maybe I have exhausted my entire indexes. In that case, I will be out. If I have exhausted it, I should make sure I should break instantly at that point in time from this main while loop. If not, then continue. When I say continue, which means that find for j now. But I mentioned that j should start off from I plus, middle length. And then the same thing here. The same thing here. Keep on moving your j. If you break out from here and you have reached the end, make sure you break again from the final loop. Again, lastly, if you were able to continue your j as well and find a proper index of j, then you will try for a k. Same thing, but making sure here that k should be more than equal to your j plus suffix length. And again, the same concept that you have matched your suffix LPS. Again, here, if again you have reached the very end, no proper k index found, simply break out. If not, then make sure that you update your minimum length, which is your answer. This is your final answer. And I will say that the length of the substring will be k minus I plus prefix length. It is exactly same as what we discussed as well. And then making sure that you increase your I so as to repeat the entire process and ultimately getting a result. If in the end your minimum length is int max, answer is -1, else answer is minimum length. Because of which time is O of n plus m, and because of using your entire LPS and stuff, your space also will be O of n plus m. It is much better than your binary search approach. Now, please make sure that we complete the light target and make sure that you check out LPS. Now, obviously, LPS for many people seem hard, but if you just watch this one video, you will realize it is not that hard. And also it is very short and simple to write and has many benefits. So yeah, please make sure that you check out this thing. Bye bye, take care.